So we are recording now. If your video is on and you want to turn it off, now would be the time, not you, Tom. Now would be the time to do that. Otherwise, I'm going to pin you to the top so that everybody sees you and you start sharing. And otherwise, you have the con.
Thank you, Dr. Alberts. So today I'm going to talk about ChatGPT and specifically recreating literary works using ChatGPT and then evaluating those results with NLP analysis. So at the high level, the research questions I wanted to examine and explore were, I wanted to see how good ChatGPT is at text generation. That's kind of a subfield within NLP, which stands for natural language processing. And it's a way that machines interpret language in text. So specifically, I was curious about text generation, sentiment analysis, and text classification. So in regards to sentiment analysis, I wanted to see if ChatGPT can capture sentiment in a meaningful way. Like, does it make sense? And I also wanted to test some of the leading AI text detectors and see if my ChatGPT recreations could fool them. So I was kind of curious about that. And with the text generation, I kind of went down the rabbit hole of lexical diversity. How rich are certain words and how rich is a specific piece of text? So are there certain styles that are just harder to recreate and have a unique signature? All right, let's see. So the literary works that I used for my analysis, I picked 6 poems, and each one of them I feel has a distinct signature and a very unique style. So I did this on purpose. And the poems I picked are Still I Rise by Maya Angelou, Sonnet 18, Shall I Compare Thee to a Summer's Day by William Shakespeare, The Raven by Edgar Allan Poe, O Captain, My Captain by Walt Whitman, Jabberwocky by Lewis Carroll, and Do Not Go Gentle Into Thy Good Night by Dylan Thomas. So part of my process was finding the original poems and then asking ChatGPT to tell me that poem. So that would become the ChatGPT version of Still I Rise or The Raven by Edgar Allan Poe. And then this is where things got kind of fun and interesting. I would ask it to recreate that original poem, but in the style of another author. So a good way to think of this would be tell me or write The Raven by Edgar Allan Poe, but using William Shakespeare's style. So this kind of created my data frame that I used for my analysis. And I got 42 different unique poems, including the originals. So that became the basis for my data set. And that's where I started adding on my features for the more detailed analysis. So, all right. So another thing that's kind of unique about this research is I decided to do it all in Python. I took one Python course within this program. And in my current role, I am a machine learning engineer. And my team is the pharmacy machine learning engineering team. So it seemed like a really good opportunity to gain that experience using Python and kind of dip my toes more into natural language processing. So what makes Python kind of unique compared to R is that it has a really good NLP community. So there's a group of packages called the Natural Language Toolkit, or NLTK as it's abbreviated. And there are plenty of different packages available to look at sentiment, to look at feature extraction and topic and sentiment analysis. So there's a lot of pre-built models already out there. And another thing that's really nice is that it's really easy to build models from scratch using Python, just because that they have so many different sub-communities and different packages like scikit-learn, Keras, and TensorFlow, that it's pretty easy to run with an idea if you have an idea what kind of model you want to use. So another thing that I appreciate about Python is it's fairly extensible. So if you had something written in C++, it is not too hard to translate that to Python. And Python is very widely used in the machine learning community. in a lot of ways, it has overtaken R and a lot of like enterprise infrastructure teams. And another thing that I like about Python is that they're always improving their existing library. So for data manipulation, Python is actually getting much better at that. And they are releasing a new version of their pandas package that's going to be supposedly just as fast as R's data frames. I'm not sure, but I'm going to test it out when it's ready. So another thing that's kind of that I appreciate from like working in multiple platforms is that it's easy to connect to different sources with Python. There is some tool or some plugin or some package that somebody wrote to connect from a database or to a certain file or to connect to a GitHub repository. So yeah, that's why I did my whole project in Python. So the outline of my talk is I'm going to dive into kind of the details of how ChatGPT works. And then after that, I think that'll be a good opportunity to do the general Q&A. And then I will get into like the heavy subject matter expertise with the high level differences between the GPT recreations and the originals. I'll get into detail with lexical diversity. I will discuss the sentiment analysis, and I will go over my results from the AI generated text detection. And I will also talk about my abandoned analysis in this project. So if you can't learn from your failures, then you'll just keep trying the wrong things. So ChatGPT. So a little overview of ChatGPT. It was developed by OpenAI, and it was introduced November 30th in 2022. It is a large language model, and it's built on top of a neural network architecture. And that specific neural network architecture is a transformer architecture. So I'll get into a little more detail why that is really neat and interesting. So GPT stands for Generative Pre-trained Transformer. And ChatGPT is using their 3.5 version. So this is the free version. Since I started my analysis, 3 other GPT tools came out. So Bing came out with their Bing search or their Bing chat. Google launched Bard, and ChatGPT 4.0 rolled out. But that's kind of that's a paid subscription service that I don't have. So another thing that is really neat about ChatGPT is that it's a supervised reinforcement learning model. So it will take feedback from your chat prompts, and they will use it to retrain the model. So if the response was not good, you can provide comments and feedback why it wasn't good. So it is constantly improving, and they have a dedicated team of people that are supervising it and making sure that the prompts are making sense. So ChatGPT, the base of it was based on version 3, which was trained on basically 175 million different online sources. So they tried to capture the entire public internet. And the 3.5 version was kind of like their fine-tune, kind of nitpicky version of which parts they think would be most helpful. So it's a little bit smaller than the ChatGPT 3, but 3.5 is a little easier to run. And they also made it a little more user-friendly, which was nice. So what makes ChatGPT so fun? So I use it to rephrase emails or conversations that I think might be difficult. So I can ask ChatGPT, how do I say this professionally without getting fired? And it'll usually come up with something kind of funny to kind of help me through that. You can also ask for inspirational speeches by Jean-Luc Picard or even Homer Simpson. So that text generation aspect of it is really fun. I've also used ChatGPT to write my development goals for me at work. So I basically prompted it, can you give me specific machine learning development goals that I could achieve within X amount of time? And not only would it write the goals, but it would also come up with suggested timelines on how to achieve them. So if I'm working to a certain certification, it gives me 3 months and specific subtasks to try and achieve that certification. Another thing that has made ChatGPT just so popular is that it has fairly decent code help. It's not perfect, and in some cases it is blatantly wrong. And I'll show some examples later in my presentation about that. But one of my friends is into model railroading, and he uses a lot of Arduino coding. And he asked me, can ChatGPT write me code to dim lights? And I said, yeah, absolutely, let's try it. So the first thing it says is, I'm not specifically trained on Arduino, but I am trained in C++, which Arduino is based off of. And sure enough, like general dimming of lights, it was able to write that code, and it worked. But as you got more specific, it did have some shortcomings there. But I've used it for Python help at work. And it's also really neat because since it knows C++, it also has kind of a basic idea of what other languages are, even if it's not specifically trained on that language. So another thing that I think makes ChatGPT great is it's just really great at brainstorming. And it's kind of like having another data scientist or machine learning engineer that you can bounce ideas off of to see if it makes sense. So if you're trying to figure out which model might work, or if you're not sure what the best path to go about, training that model, it can give you a couple of ideas on how to do it. Granted, some of them will not work, and you can tell it did not work, but you can keep prompting it to try and get to an answer that'll work for your situation. So real quick, I wanted to talk about what makes that GPT transformer aspect of the GPT model so interesting. So most previous neural networks that were built on text mostly used a recurrent neural network structure. And basically, it would look at each word individually and sequentially. What's different about ChatGPT is that it can do positional encoding on those words. And it also has this built-in process where it pays attention to the sequences of those words. So GPT transformers were built to be translators, which I thought was really interesting. So in a Google talk by Dale Markowitz, she gives a great example of how if we want to say the European Economic Zone in English, if you used a recurrent neural network, it would try and take each one of those words and then do the direct translation to French. But in French, the position of the words matters, and there's also gendered nouns. So in French, the European Economic Zone would go something like la zone économique européenne. So that is not the same order as the European Economic Zone. And what's neat about it is, as GPT trains on more text, it can see those patterns and the sequences with those words to understand where those relationships belong. So it constantly improves upon that. And that's also what makes it sound so convincing with its responses. So, all right, slide. All right, so I think this is a good pausing point for the high level talk. Does anybody have any questions or general comments?
I actually do. Hi, Tom.
Hey.
Can you hear me okay?
Yeah, I hear you.
Yeah, okay. I have a few questions. I probably won't be around for the second Q&A. So my first question was, what is ChatGPT? So you took care of that really well. I find this topic really interesting, in the fact that the transformer takes into consideration the linguistics of the language, instead of like looking at each individual word. It's kind of taking into context the linguistics behind the language. I think that's pretty cool. First, what was the drive behind this topic? Like, why did you choose to do this? Are you a poet or an author yourself, or I was just curious as to why you chose this project.
So it's kind of funny. I didn't really know what I wanted my thesis to be in January. And I was listening to a podcast called No Dumb Questions, and they started talking about ChatGPT. And one of the topics they brought up is, one of the speakers is a pastor. He said, can it give me a sermon for the Sermon on the Mount, and how good is it?
Oh.
And it basically gave him an outline of how to do the sermon. And then he's like, and okay, this is convincing, this sounds good. And he's like, and then it falls apart completely here, and it made up a whole bunch of stuff. But like, it was like structurally helpful. And with poetry and just the English language in general, my grandfather was an English professor. So like he
Mhm.
added a love of stories and just general literature to me at a young age. So I've always had that kind of general interest. And yeah, so, and when it came to like analyzing text, after I listened to that podcast, I'm like, ChatGPT would be a really cool topic. And then I'm like, I don't think I can have it analyze the old man and the sea for me because that is kind of long. So,
Mhm.
we're kind of like that sweet spot of where the length wasn't too much, and I wouldn't have to segment my responses as much.
Awesome. And then kind of going off of that, analyzing text, it sounds like there's been a lot of new text services come about. Your Google, Bing, you said, who else? There's just all these analytic net, or you know what I'm saying, just that have just come out. Do you think that's related to our reliance on social media communication? And I don't know, I'm just curious, like, why do you think now we're having all these analyses tools that are specifically for text when we've had books and literature forever? But so I was just kind of curious about how social media's role is in the development of all these services.
Yeah, I think you bring up a really great point. So I think what made this possible was just the development with the transformer technology, because chatbots before GPT were not very good. I remember the old chatbots, and they had very structured and specific responses. So once that transformer technology evolved, somebody decided, hey, you know what? People talk in a certain way. And if they want something very specific, they're going to go to Google. But if they want to be conversationally comfortable, a chatbot that uses this new transformer technology is probably going to be a lot easier to convey, knowledge than just, looking it up in a book or Googling it directly or reading research articles or going to your library. So that's a really good point. But one of the things I noticed with Bing, so I downloaded it on my phone. I'm like, okay, this is kind of nice. And I use ChatGPT on my phone and on my computer. But the way that it acts like a messaging app. So it feels a lot like Facebook Messenger, or it feels a lot like iMessage. So it's not as, I don't know. They definitely took on that social media aspect, where I feel
That
like GPT, it's more like, it's less social. It's kind of bare bones.
yeah, I get it totally. Okay, well, good luck during the second half. So, and thank you.
Appreciate it.
Cool. Any other questions? Adam, you?
I'm really enjoying this. I'm really old, so I don't even know if you have ever heard of ELIZA and Raptor, which are really fossils. And we were talking about that. I was in Phoenix as I was reading your paper, and just astonished at the growth in our own lifetime. It is truly exponential.
It's funny you bring up ELIZA, because the company I worked for about 10 years ago, we were using ELIZA to transcribe call quality related stuff. And we since moved on to another platform, but I remember pulling ELIZA data. So I have some experience with it.
Well, thank you very, very much. I'm most impressed, and I was honored to be invited to sit in on this.
Thank you.
Awesome. But yeah, I think that increase in processing power and the way the tools have just, I mean, and even this lab that I keep showing off, I mean, the idea that it's, we got a grant to fund it, but this would have been unaffordable 10 years ago to have power like this just sitting in the room for students to work on. So it's very cool. So anyway, with that, Tom, we'll let you get on to part 2 and the fancy part. So I'll get out of your way and you take over again.
And to kind of build on like what you have going on with the lab in the data science department, what's really helped these GPT and these transformer models take off is also the development with the GPU technology. So what's really neat is that if you have a really great graphics card, a transformer model can run in parallel. So you can run multiple inputs and instances at the same time. So you can parallel process. So it allows you to analyze data at an exponential rate almost. You're Your limitation is how much RAM and how much SVR RAM you have. So that has also really taken off. All right, so at a high level, one of the things that I had to do before I got in too deep with all the poems is I wanted to see if what ChatGPT thought were originals and what I had as source originals were even close. So when I built my data set, one of the things that I did was I labeled each one of my rows. And how I distinguish originals from GPT and GPT poet specific recreations is I will have the name of the author, and then I will do an underscore. And if it says poets, that means it's Edgar Allan Poe's original. If it has underscore GPT, that is the GPT recreation of Edgar Allan Poe's The Raven. And then for poetic styles, if it is Edgar Allan Poe's version of Walt Whitman's "Oh Captain, My Captain," it would say Edgar Allan Poe underscore WW for Walt Whitman. So that'll come in handy with some of the visuals that I have to share a little bit later. But one of the things that kind of threw me for a loop was that it had ChatGPT had a hard time recreating The Raven. So that recreation was missing 787 words. So that is a significant amount of text with a poem. So I was a little surprised about that. But what I found really interesting is that it didn't seem to struggle with shorter text. So "Do not go gentle into that good night" was spot on, same number of words and same number of terms. That's pretty cool. And then William Shakespeare's sonnet had only one word difference. So I just wanted to do some exploratory analysis before I went too deep. Let's see, next. All right. So the next part of my analysis was I wanted to get into lexical diversity. So lexical diversity is a way that we can tell how rich are the words within text. And what I liked about this idea is that it gives us a benchmark for the language complexity. So it's really hard to say, or it's really hard to express how complex certain words might be. But if you're using enough different words within a small piece of text, you're going to increase your score. It also doesn't take into consideration how good those words are. It doesn't weigh them that way, but it gives you a benchmark to measure them at, which I really appreciate. So to analyze lexical diversity, I used a package called Lexical Richness, and this package had more variables than I knew what to do with. So within lexical diversity, there is kind of a standard metric called type to token ratio. And what that measurement gives you is it'll take the number of unique terms within text, and then it'll divide it by the number of total words. And based off of that ratio, you'll figure out how lexically diverse something is. Now, the problem with that calculation is that it's very dependent on text length. So if you have more words, you're probably going to have more terms or more unique words. And so what was really interesting with this package is it gave me more variables to try and better handle text length. And with poems, generally speaking, they're shorter. So I wanted to make sure that I was using a meaningful benchmarks. So when I first started this analysis, which kind of alluded to earlier, I was considering like recreating famous prose, but GPT has a 3,000 word limit. So I would have had to do batches of different prose. So that is why I decided to do poems. They're generally shorter, and for the most part, ChatGPT can handle it. So another thing that is kind of interesting to consider is that if you want to use ChatGPT as a pipeline and use their API and connect like your social media to it for your company or for your business, OpenAI charges by the word. So it's about 1/10 of a cent or 100th of a cent. But the more words you have, the more they'll charge you for the subscription and the service. And some companies will charge you by the type, so by the unique words that are used. So this comes into handy when you're trying to estimate how much it's going to cost you. So the biggest challenge for the lexical diversity was figuring out which ones should I use for my analysis. So to get kind of an idea of which ones might be statistically significant, I used a correlation heat map. And what's kind of neat about this is it gives you an idea of the values or the variables that kind of stand out. So if there is a red cell, that indicates that there is a positive correlation. The closer a value is to the number 1, the more positively correlated that feature is. Now, the closer the value is to negative, or to -1, the more negative of the correlation there is. So kind of the issue with all of these benchmarks and all of these measurements is that they basically use the same base to try and come up with a score. So they all use words and they all use terms. And they're all basically different iterations of the same calculation. So just by looking at this, I thought, it looks like Summer, Dugast, and Moz, probably HDD, and vocad kind of stand out as potential measures. But I decided, I'm like, okay, this is not telling enough. And if I had to only pick 2 to use for my analysis, which would be really good diversity scores to use as benchmarks. So to do this, I took it a step further and I decided to do some principal component analysis. And what I really like about this, as long as your data set has numeric features in it, it'll break your data set into components, and you can specify the number of components that you have that explain the majority of the correlation in your data set. So it kind of hyper focuses the attention. So I wanted it to pick 2 components for the 14 variables that existed. And so this is kind of this is a more of a preference thing, but one of the things I did not appreciate with Python was it was harder for me to figure out which features it selected from my data frame. So this was the results of the PCA analysis, principal component analysis, and it'll tell you the descriptive, like the summary results, if you explain the explained variation. So the first component, which is right here, explains about 61.78% of the variation in the model. That's good. And you're like, okay, that's helpful. And then the second component, which is this section right here, explains about 31.69% of the total variation. But one of the hardest part was for me to figure out, okay, these are the highest numbers within that first component. What feature is that? So I had to look it up, and it's Moz and Dugast. So, and then the second component was a lot easier because it was very obvious that it was words and terms, the first 2. So real quick, I'm going to share my, I'm going to jump to my white paper, and I'll show what that looks like. Oh, and to further analyze that data set, I performed cluster analysis to see if there's any distinct groupings by author and by poem. And I use cluster analysis for a few parts, for a few areas within my research. And to pick the number of clusters, I use the elbow method. And kind of the neat thing with the elbow method is that I feel like Python does a pretty good job about labeling where exactly the elbow or where the curve begins. I felt like I struggled a little more in R trying to figure out where that bend in the elbow is. But at this point, that's kind of the optimal point of the number of clusters to explain the data within your analysis. So there's 3 possible groups within our lexical analysis data set. So this is my visual for the clustered analysis. Now, I'm going to get into the calculations and what they mean real quick. But for Moz, it's an index score. So the lower the number, the more lexically diverse the text is. for Dugast, the higher the number, the better. So kind of the standouts for this data set are, no surprise, it's William Shakespeare. That's his original is there. So that's the original poem, the Sonnet 18. The GPT recreation is a close second with those scores. And we can see the Lewis Carroll rendition, Maya Angelou rendition, Dylan Thomas. So Walt Whitman was kind of like the second poet that was in that area within that clustering. So I thought that was really interesting. So here we go. So how is it calculated? And I know I kind of discussed the type to token already, but what was interesting was in the documentation for lexical richness, they provide the calculation for each one of the variables. So to save on time and space, I decided to pick the calculations for the ones that I'm using for that were most the statistically most significant for my research. So for Moz, it's an index, and it's the log of the words minus the log of the terms divided by the log of the words squared. And if you look at the Dugast metric, it's the inverse of the same calculation. So what I found interesting with this analysis was that each subsequent metric is just a different iteration using the same base calculation, and then just doing a different take on it. And with the HDT and the vocab, what was really interesting about those is they took random samples within the text and they would compare it to the probability of the score depending on the number of samples. So each metric got more and more complicated and more refined. So it was really interesting. But the kind of the big takeaway from the lexical diversity analysis is that William Shakespeare was really one of a kind when it came to his poetic prowess. And real quick, with a lot of these images that are within my presentation, I used DALL-E 2 to create a lot of these images. And you can tell that they're AI generated because OpenAI requires a watermark on the end of, at the bottom of each picture. Bing also does this, and they have like a little Bing symbol in the corner of all of the things that you generate with them. So I prompted DALL-E 2 to create a cartoon version of William Shakespeare writing at a desk with a quill in his hand. So I had kind of fun with that. All right. So the next part of my analysis was sentiment analysis. And just from my own professional experience, I was part of a team for a while that did patient satisfaction scoring. So we had kind of an old survey system where we would have a vendor call members and ask on a scale of 1 to 10, how likely are you going to recommend our services to a friend or family member? And we would get those responses back, and we would calculate something called a net promoter score. It was very time consuming, and realistically, I think there's probably better ways of doing it now, but it was contractually obligated. So that's how we did the sentiment analysis that way. So for sentiment analysis within the poems, I got to explore within that Analytic family, that natural language toolkit. And I decided to use a text blob. Just because it is really simple to use, and it gives you 2 metrics that are kind of telling for how your data, what your data looks like. So the first score it'll give you is called a polarity score. And this score is the closest thing we have to like positive or negative feedback. So it's on a scale of -1 to 1. So the closer you're at a -1, that's more of a negative sentiment. If it's at 0 or close to 0, that's more of a neutral sentiment. If it's at 1 or close to 1, very positive. And the other score that text blob gives us is a subjectivity score, which is pretty neat. So this is on a scale of 0 to 1. And the closer the score is to 0, the closer the author is trying to convey a statement of fact. The closer a score is to 1, the more subjective and opinionated or expressing beliefs the author is conveying. So with that, I decided to create some scatter plots to kind of explore those trends and see how they looked. I prompted DALL-E to create Edgar Allan Poe with a raven body, and I also asked for its idea of what a Jabberwocky would look like. So here we go. I'm going to return to my white paper. Oh, and for the lexical diversity within my white paper, I also showed the exploratory clusters for those other features. And one of the things that stood out was that Maz and Dugas had the straightest line. And since they're like the inverse of the same calculation, I was not surprised by that trend. So these are my sentiment scatter plots. And I just want to say real quick that Plotly is a lot of fun to use. And it saved me a lot of time when I was trying to figure out if I should build a dashboard to kind of express or to show the sentiment analysis. And what I realized was that if I use Plotly, I can do pretty much everything I need to, as long as I just call out that you can click on the different poems to figure out which features you want to drill down into. So one of the things that I noticed with Edgar Allan Poe's The Raven with the sentiment analysis is that the original is kind of what I would expect. Very close to neutral on the feeling, because Edgar Allan Poe has kind of a stoic style himself. And then with the subjectivity, it's a little, it's expressing ambiguity. There's a little bit of ambiguity. It's not very statement of fact, and it's not really expressing too many feelings. It's kind of, I don't know, deadpan almost delivery would be the best way I could describe it. But what I found really interesting was that when we looked at the Raven poem written by ChatGPT with William Shakespeare style, was that it was incredible. It was way more upbeat or way more positive than Edgar Allan Poe's original version. So I thought that was kind of interesting. And also Lewis Carroll was much more upbeat as well. So that's not what I really expected from those styles, but it was interesting. For Jabberwocky, a really quick call out with Plotly. If you have two data points that are close to overlapping or overlap, one kind of fallback or one kind of criticism I have of Plotly is that if you have overlap, it just darkens that data point. So the original and the ChatGPT data point had the same scores. So that is expressed with just a darker filled data point. But one of the things that surprised me about this poem specifically was that Walt Whitman's version of this poem was just way more positive than anyone else's. And the Dylan Thomas expressed more feelings and opinions than the other recreations. And what was not surprising to me at all was that the Edgar Allan Poe version was way more negative, had a more negative sentiment. And it was, I would still say it was fairly stoic. It's not quite at 0.5, but yeah, for such a serious poem with a lot of themes about maturation and going through the natural stages of life, especially losing a parent, this is kind of what I expect with Edgar Allan Poe style. So I thought that was really neat that it could do that. Let's see. All right, and another poem that I wanted to kind of evaluate and show was Do Not Go Gentle Into Thy Good Night by Dylan Thomas. So like the previous plot with Lewis Carroll, the GPT and the original version had identical scores. And that's not too surprising because within that variance analysis that I showed earlier, they matched up pretty much word for word. So I wasn't too surprised by that. But I think what threw me for a loop here was that the Edgar Allan Poe version of Do Not Go Gentle Into That Good Night was way more positive than any of the other versions, and it expressed way more emotion and subjectivity. So I thought that was a very interesting find. All right, I'm going to go back to. All right, so the last major part of my research was testing the AI text detectors that exist right now. So for the two that I chose, I decided to use OpenAI's text detector. I also used a detector called GPT-0. So real quick, I'll just share my screen on how they look and what they do. Let's see. Oh, it's not this version. Hold on. Here we go. So the AI text classifier, it'll allow you to enter in text within their text box. And I think there's a limit to how much you can put in, but the text length has to be at least 150 to 250 words. So some of the poems, it cannot accurately classify. And after you classify it, it'll give you a result. And the result is basically a text, a response of very unlikely, most likely, highly unlikely, not at all likely, AI generated. So for each one of the poems and each one of the recreations, I pasted the responses, and I would copy basically the classifier results, and I would append it to my data frame for the analysis. So what was kind of neat about OpenAI's version is, even though they're not giving you numbers to work with, which I really prefer, they gave you more options with the output. So some of the text was just way too short. I think Dylan Thomas's "Do Not Go Gentle into Thy Good Night" and Sonnet 18 by William Shakespeare were just, some of the versions were way too short. All of them were, or none of them were caught or even said most likely generated by AI. There was a lot of ambiguity in their ranking system. So unclear if it's AI generated. That was as close as we got to if it was generated by AI. And it's funny because only 6 of the original poems were written by a person. Everything else was just another recreation. So one thing that I want to call out for this analysis is that it's not necessarily a fair test, because I used a text-based source to kind of do my AI generation off of. It's not the same of writing a paper or a lengthy piece of text off of just one subject. I used a very specific poem for it to recreate. So let's see, take from the current slide. All right. GPT-0. So the cool thing about GPT-0 is that it was developed by a 22-year-old computer science major with a minor in journalism at Princeton. And basically, he was on a mission to try and figure out how do we defend against AI-generated text? Because in the world of academia and research, he was concerned that it'll be very hard for people to tell if it was written by a person, and where's the accountability lie with that? So Edward Chan came up with this incredibly neat AI text detector, and I'm going to show that right now. His was very interesting. And this is what this got rave reviews throughout a whole bunch of different news sources. So when I was looking to try and figure out which text detectors to use, OpenAI did not fully release their text classifier yet, so I started here. But it follows a very similar pattern as the AI text detector. It gives you the option to copy and paste your text in. The one thing that I do like is you can pick a file and upload it, and then it'll run your results there. So very similar to the OpenAI text classifier, I copied the results of the analysis, and I appended into my data frame for all the analysis. And one of the things that I appreciated about this text classifier specifically was that it gives you perplexity scores and burstiness scores. So a perplexity score looks for randomness within the text. And the idea behind that is AI text generators are going to fall into certain patterns and using certain words. So the more perplexed something is, the less likely it was AI generated. And kind of the accompanying metric with that is the burstiness score. So a burstiness score is basically the variation within perplexity. So people are going to use certain words, and their paragraphs and sentences are going to vary in length, whereas a machine or AI text generator will fall into certain patterns and habits, just the way it was built. So the combination of those two data points, I added those into my analysis. So I really appreciated these extra scoring methods. All right, so the next question to ask is, okay, that was really neat, but like, how do the various pieces of text measure up? So share my paper. Oh, and real quick, a call out. GPT-0 also did not specifically imply any of them were generated by AI, but there was one that it wasn't too sure about. And what was ironic about this result, this count one, is that that piece of text was Maya Angelou's Still I Rise original, and it scored the highest of all the other burstiness and perplexity scores combined. So I used a bar chart to kind of illustrate the relationship of those combined scores and just get an idea of how they rank. So what was interesting was that Maya Angelou's, clearly her original stands out as the most. Like that perplexity and burstiness score is just above and beyond everybody else's. But what was interesting, an interesting trend with her recreations, is that most of them kind of sit at the bottom in terms of perplexity and burstiness. So it looks like ChatGPT struggled to kind of follow that style with the perplexity and the burstiness. So I also did cluster analysis to kind of evaluate the results from this. I wanted to see if there was, distinct groupings based off of perplexity and burstiness. And for that cluster analysis, I removed Maya Angelou's original poem from that analysis. Again, I used the elbow method to pick the number of clusters. Ironically, all of my analysis pretty much used 3 clusters for this research. So if we remove Maya Angelou's Still I Rise original poem, it looks like in terms of burstiness and perplexity, Walt Whitman stands out as a clear perplexed and bursty writer, which I thought was really cool. The GPT rendition of "Oh Captain, My Captain" just surpasses the other data points. And close second was his original poem. And William Shakespeare again pops up as a kind of a standout with his burstiness and perplexity scores. So yeah, the next part of my presentation, I'm going to discuss the things that I explored without success. So some other areas that I wanted to see if I could I could do some interesting analysis on were, I found a Python package that would classify your text based off the iambic pentameter that it notices within your file. I'm like, oh, this would be really interesting. So I created 42 files. I spent a weekend running each individual file to try and get a result. And after I completed that task, over 3/4 of the text were classified as the 15th century. And since none of my poems were within that century, I decided to kind of just walk away from that. Another thing that I tried to do was I wanted to measure meter, and I wanted to do that by each poem. And if it doesn't have meter, that's fine. Just give me a score of 0 or skip it. But I prompted ChatGPT to help me with this, and I'll share some of my experience. I'll share my output, my exchange with that to try and figure that out. I was also going to try and recreate some of the analysis using Bing Chat and Bard. So I'll kind of get into that next. But so this was my attempt trying to figure out meter using ChatGPT. So I would take the code and that it prompted, and I would suggest. And I said, okay, that package is not working for me. Can you suggest something else that might work? And about after the third or fourth prompt of other ways to measure meter within text, it started suggesting things that just don't exist. So one of the packages it suggested was PyMetRepR. I'm like, okay, that sounds really interesting. I went to the IPy website, and this is kind of the equivalent of R's CRAN repository, to see if it even exists. And surprise, surprise, it doesn't exist, and it didn't exist when ChatGPT was initially launched. So I was a little frustrated by that, but I decided to move on from that analysis. The next part was I tried to use Bard. My wife and I signed up for early access to Bing Chat and Bard, and she got access to all of them first. So she gave me her login, and I was like, hey, can you write The Raven by Edgar Allan Poe, but using William Shakespeare style? And Bard did not want to do that. And at first, Bing Chat told me that that could violate copyright, and it didn't want to do that. But what was interesting is that they put in an update like a week or so ago, and it started actually doing the recreations. But like Christy pointed out, it's a little bit harder for me to work with the way that it generates text. It's a little more like copying from a text message rather than, I don't know, like a file, a direct file. So you have to scroll a lot more to try and figure out what you're looking at. But some cool follow-up analysis would be to try and do similar analysis using ChatGPT 4 or the new improved Bing Chat. So yeah, these are the links to the original poems that I used for my analysis. And here are the AI links I used for this research. So I had to call out the lexical richness documentation, DALL-E for generating the really cool images that I used in my presentation today, OpenAI Chat, their text classifier, and GPT-0 that everyone built. So any questions?
All right, first, yay. Again, on Zoom, we don't hear the applause, but that was great. You couldn't also hear us giggle when you were talking about a couple of the things, but does anybody have any questions?
I have one.
Go ahead.
So when you was doing your analysis for the GPT-0, the AI text classifier, do you think that it had the reason it scored high on the last analysis is because it had more words than the other one? So like it was from the white paper.
Yeah, that's a really good question. One thing that they didn't share with that GPT-0 text detector is they didn't say what text it was already trained on. So I'm wondering if that it looked at like a collection of poems by Maya Angelou, and it was just already trained on that and said, okay, this is a really complex piece of text. So I'm wondering if that stood out as such a statistically significant outlier that it was just already trained on it, or maybe even possibly overtrained on it. So.
Okay. And the poem that you had did by, I think it was the Agner Allen, the Raven, where it was the words that was used in the one of them, I think it was the plurality and simplicity of one of them, where it had it had did well when you had did the clustering. So like when you did the clustering, it stated that majority of the EBO was at 3 clustering, but it had ranked high when they had did 2 clustering. And that once again, that was in the white paper towards the bottom of the analysis when you had filtered out. So in between after this, it was yes, this paper right here. So yes, this right here. So when you had said, I think it was no, it could have been Dylan. So it was around 1,000, where it was 1,000 words. So it was probably one of those where it was between. Yes, okay. The yellow ones, I couldn't see it. It was a high percentage. Yes, it was there. So was it because it had was it, I know you said it might have, was it, you think it was familiarity where it was how it was able to seek to make that be specifics in that general frame? So like the score on this one, did it rank the same as the 0 negative to 0 1? Was it a different scale?
Yeah, so with the sentiment analysis and the classification analysis, they had to use separate scales.
Oh, okay.
Yeah, so the nice thing about sentiment analysis is that you only go to -1 and 1, and you can go from 0 to 1 with the subjectivity. But with burstiness and perplexity, it can go up to like 3,000.
Oh, okay.
Yeah, it's a wide range.
Oh, okay. Okay. Well, thank you, and it was a nice presentation.
Thank you, Sterling.
All right, cool. More questions?
Hey, this is Mark.
Hey, Mark.
Hey, so really appreciated the presentation, Tom. My question is kind of comes up on precision. So what happens when you do this multiple times and multiple trainings? So I guess kind of question number one is, if you go back through and tell ChatGPT to give you the parity or give you its approximation, 5 times through or 10 times through, how similar do you expect those results to be? So that's kind of the first part of the question. And then the second part of the question is, kind of related. If you go back through and then tell ChatGPT, okay, I want to do 5 different Edgar Allan Poe poems, 5 different Shakespeare poems, do you kind of expect to see the same trends coming out across these different poems, where they're, because the large language model has been trained on the entire body of works, let's say, they're going to trend towards a specific tone, versus, okay, no, it's still going to be somewhat random, or it's going to be maybe poem dependent.
Mark, you brought up a really great point. So one of the challenges that I wanted to do with this research was I wanted to make it like as machine learning specific as possible, but it was really hard for me to get enough data and create enough data to train a model and see what like the 100th iteration of the recreation of The Raven by Edgar Allan Poe would look like. But so I think it would probably take probably a few different iterations of running similar models. And the interest, or the kind of the challenging part with large language models, is that it's a snapshot. Since the model is always improving, when I ran this analysis in February, I might get different results. But what I kind of expect, or what I hypothesize, is that if I were to rerun the model based off of what I have today, I would suspect that certain sentiment trends would not fluctuate too much. I would not expect the burstiness, or I would not expect the classification piece to change that much. I did check it today, and a lot of the different poems had the same scores. So, but in terms of like the lexical diversity, I do think that might change just because the language model is constantly improving and constantly changing. So the more it gets trained on, the more selective it might be on certain words that it uses. So good question.
Thank you.
Now that ChatGPT 4 is out, maybe 3.5 isn't getting as much update. I mean, it could even be.
Well, they still have it, and for the long time before ChatGPT 4 came out, you could get ChatGPT Plus, and the benefit was that sometimes it wasn't down. So, like, it's more up than it is down. So, like, another challenge with this analysis was I had to do it at odd hours to make sure that I could connect to ChatGPT. So, yeah, but yeah, I don't think ChatGPT 3.5 is as hot of a topic right now. I really like it and I still use it, but
Yeah. Cool. Any other questions? One of mine is always, when the AI overlords take over, will they remember you fondly and you'll be treated well by the machines when the.
it's funny you should ask that. I'll have to share my prompts with ChatGPT. They're very polite. So whenever the computers take over, I try to be very respectful so they'll remember that at least I was polite.
And of course, you taught it literature, so it should remember you with joy.
Oh, I think in some of my examples I said thank you. But no, we'll see. It's very neat. There's a lot of people that are afraid.
We'll see. Awesome. Okay, so this is where, if we were in an old style master's defense, the committee would go out of the room and we would huddle for a minute, and it would be very stressful, and then we would come back in and tell you if you passed your defense or not. I texted with Adam and I waved at Wayne, who's across the room, and Shanshan is sick, so she's not here. But you passed your defense, so yay! You do have a couple weeks till the final version of the paper is due in the graduate office, and I know some folks had some comments and stuff, and you were still working on it yourself. So I think, the document we turn in can still add to things. Compared to some of the other ones in the cohort, your paper is more of a paper. So in that sense, it's easier to put into a format than, Aaron's genetic models or Christie's education course. She had a whole course, so it's hard to turn that into a thesis book, but yours is more of a paper, so that part might be easier. Otherwise, this was great, and I don't know if you have any other thoughts about the program or anything. This is your chance to publicly.
So I was one of the first cohorts when the data science certificate started.
Yeah, so you've been here a long time. You were here when we first started going, and yeah, took some time off and came back. Yeah.
I think the program has evolved quite nicely. I think a lot of it was very asynchronous at first. So like, I kind of felt like it was, you just go from one class to another. But I feel like with the addition, with the masters and the 5 other classes, I can kind of see how things overlap. And it's not like I see them overlap and I do the final assignment and turn it in. So that part was really nice. And then kind of like the meeting once a week and doing the social interaction, I think that was a really nice positive, because you also get to see what other people are doing and their work, and seeing getting their ideas too. So that was a kind of a nice enhancement for the program.
Good. Good. I guess another question that's not about your paper itself, but you basically, you had the one Python class and then you taught yourself Python. And one of the things we claim is, we, instead of doing kind of a breadth approach, we go deep into R and then we talk about it with the idea that you can learn a second language faster. And I know you've coded before, but was Python pretty easy for you to learn and to learn the stuff?
Yeah, so I think, taking Professor Liv's class was incredibly helpful. And my current work, I don't use Python too much. I'm still more on the data side. But one of the things that I appreciated was that, having that base understanding of how things work helped a lot. And I think the hardest part was setting up Python within R in a way that it would work and run. So creating your own virtual environment, then using all the versions of Python that are compatible with like your packages, and then remembering to start the kernel or initializing the kernel every time you run your code. So there were some things that, like, I don't know, it's kind of like the simple reset and try again method, and
Uh-huh.
the run. But yeah, no, I think
Okay, good. And then you used Quarto, which is a relatively new product that allows R and Python integration, and that worked okay. That was
yeah, that worked pretty well. So one of the challenges I ran into was I was trying to hide my R setup, but since my environment was set to Python, it didn't know what to do with that text blob. And
oh,
when I preset it and I said, okay, let's do R and then flip it back, it did not like that. It stuck with R, and then it changed the formatting of all my like tables and outputs.
uh-huh.
I'm like, okay, I'll leave that in. That's not too bad. But one of the things that I appreciated, and I think Dr. Thatcher kind of brought this up uh, when he was talking about Quarto, is that it's really nice to like, it does a good job of connecting your citations. So you have to use like another tool like CiteBib or something like that to format them in a way, and then you can append them very easily. And then I don't know, I thought that was pretty straightforward.
Yeah.
I like that aspect of it.
Nice, because that, I mean, I'm still learning Quarto myself. I mean, I was just saying when we started that I'm basically using it as R Markdown and then sticking a sparkly bit every once in a while. So that is very cool. All right, any other questions or anything from anyone? Otherwise, thanks so much for joining us. Thanks to Tom, this was great. And again, we'll get that all done. This is our last thesis defense for this cohort that for the May graduation, but we're going to have another clump coming kind of in the early summer, May or June. So look for that for August graduation, and then another clump in August and December. So we should have a whole bunch more of these talks coming. So watch for that, but including some of the people on the screen who have to turn their cameras on. But this was great. So yeah, if there's nothing else, thanks, Tom. We'll talk to you soon, and we'll talk about all the detail stuff. But this was great. So have a great day, everybody. Bye.